Welcome everyone to our talk. I'm Sohail and today I'm going to present our work SLNET, which is the largest dataset of third-party Simulink models. MATLAB Simulink is widely used in model-based design, where engineers typically design complex cyber-physical systems using Simulink's graphical UI. This in turn has attracted the research community to study Simulink model properties to develop techniques to predict model smells and automatically generate test suites. Most of these works have relied upon proprietary models for evaluation, citing lack of easily available real-world models. Such evaluation strategies have severely affected scientific progress, as replication of the work and comparison against it is next to impossible. To overcome the issue, there have been efforts in the past to create a large collection of Simulink models. For instance, Chowdhury created a collection of over 1,000 Simulink models from various sources. Bole recollected the updated version of Chowdhury's collection to understand its current state for empirical research. While a great first step, these collections suffer from several issues. The collections contain duplicate and empty projects, that is, project without any Simulink models in it. Also, it is quite difficult to sample a project based on specific properties as they do not provide fine-grained metadata. To address all these issues, we built SLNET. Let me show you how we built it. First, we create a GitHub API with keyword Simulink and parse MATLAB Central's RSS feed to download potential Simulink projects. We ensure that each project has at least one Simulink model in it. Then we discard projects aimed at generating synthetic Simulink models and also discard those which do not have any license file or have closed source licenses. Then we build a model metric collection tool called SLNET metrics. In order to understand what these model metrics are, let me show you how a simple Simulink model looks like. The basic component of a Simulink model is a block which can represent equations. Depending on the block type, a block may accept input, perform some operations, and then optionally forward the result via connection lines to other blocks. To deal with increasing model size, blocks can be grouped together in a subsystem or in a separate model. In the slide, the block diagram you see up top is packaged into a single block which is later referenced in a separate model. Our SLNet metric tool extract all of these metrics and store them in a metadatabase. This is the full list of model and project metrics we collect. I'll not go over these in the interest of time. Lastly, we remove duplicates using a heuristic, that is, if two projects have the same number of model files and there is a bijective mapping between models in terms of its metrics, we mark them as duplicate and keep only the earliest created project. In doing so, we filtered almost 30% of the projects we initially collected. Based on the collected metrics, we did lightweight analysis of project engagement distribution. The engagement distribution in SLNet is long-tailed, as you can see on the table, meaning a small number of projects are very popular. Then we heuristically searched for keywords in project description and tag, and found that the majority of our projects are from electronics domain, but SLNet contains projects from automotive, energy, and other domains as well. We use the SLNet metrics tool to extract model metrics from the model in SLNet. The tool identified over 1,000 library models and 9 test harnesses. We extracted metrics from the remaining 8,000 models, which in total amount to over 1 million blocks and connection counts. When we use Simulink's built-in API that earlier works have used, the counts are over 3 million. Moving on, we envision several potential research directions with SLNet, including our primary goal of providing easily accessible human-authored Simulink models that can be sampled based on specific model and project properties, and also make it easier to compare results as well as investigate technique scalability and generalizability. We hope that this data set will enable machine learning-based research, as it typically demands a large training set to work well. In conclusion, SLNet is the largest self-contained redistributable dataset of Simulink models, and the tools to mine and extract model properties are open source and extensible. Lastly, I want to thank NSF and MathWorks for funding this research. Thank you.